Part 2. So in the most recent time history, as we'll see, this linear ramp up is no longer maintained because we are no longer building new refineries at the rate which is needed. There are several reasons for this. The reasons don't matter. What matters is the simple fact that for almost the last 10 years or so, we have saturated worldwide refining infrastructure. We have no ability to distribute any more than 87 to 90 million barrels a day, regardless of demand. We have reached the physical limit on oil distribution. This means that the price of a barrel of crude oil is no longer subject to simple supply and demand. The demand can be anything. The supply is limited to 87 million barrels per day. It's been that way since 2005. Hardly anybody knows this. This is an important part of sort of energy literacy 101, is to recognize that the distribution of oil on a daily basis on the planet is now a constant. And the total production waveform looks like that. We've already gone through it. Okay, so because of that saturation effect, there can be no peak oil. This peak oil is smoothed out into a plateau because of refinery saturation. This is good because it slows down the rate of GHG emissions somewhat, and it also gives us more of a window. We will run out of oil less fast in a plateau waveform than in this peak waveform. And so the plateau waveform looks like that. There's about a 6% peak-to-peak fluctuation around this constant value. In the future, this plateau will start to have a long, slow decline. Whether that happens in 1 to 4 years is indicated here, probably unlikely. Will it happen in 5 to 10 years? Probably likely. So that gives us a very simple idea about what the future supply and demand is for oil. In the future, there will be no supply. We will simply never find enough conventional oil to close this increasing gap. And the amount of unconventional oil, as in tar sands or deep sea marine sediments, or in newly discovered natural gas deposits, none of that is enough to make up this increasingly very large gap. Most likely 2030 to 2040 is the time frame at which the production of and distribution of conventional crude oil in the world will be 10% of its current value. And of course, another waveform of business as usual is this steady increasing content of atmospheric greenhouse gases, in this case CO2. We are heading toward 400 parts per million. The Planetary Engineering Society will host a party when we get there for that achievement. And you can see that there's no sign in the overall data, this is measuring the throughput of human activities, for a decline associated with the global economic meltdown in 2008, 2009, first half of 2010. The Earth didn't see that. And so we can conclude with 2 points. What is our current greenhouse gas budget? Well, CO2 is at 398 parts per million. Methane is at 1.8 parts per million. The equivalency of CO2 plus methane is now at 452 parts per million. And we see here we have a factor of 34 and a factor of 21. Very long story short, the IPCC process has finally revised methane chemistry to the correct absorption coefficient. So this factor is now 34 rather than the factor of 21, which has been used for the last 20 years. 70% difference. As a result of this, factor 34 coupled with a 3% increase in pipeline leakage means that the burning of natural gas to generate electricity is putting more combined greenhouse gas, carbon dioxide 2 equivalent into the atmosphere than if we just used coal-fired plants. Not a good thing. And finally, this shows out how we're changing out coal to natural gas and therefore increasing our greenhouse gas budget. I only got 15 seconds left. We have reduced our greenhouse gas emissions by 10% over 8 years. Big deal. We're still using 80% of our total energy from fossils. This is business as usual.